Welcome viewers, today we have a task to do on logarithmic equation with different bases. But before we jump into that, I would like us to refresh our mind on some laws of logarithm. Number one, if I have log AB base P, I can express this as log A base P plus log B base P. This is number one. Then number two, if I have log A base P to the power n. Now in this case, the base has the power n. So how do we resolve this? It will become log A to the power 1 upon n base P. So what just happened? We have just transferred the power of the base here to become the power of the input. And when the power changes, it's now a fraction. So please take note of this log number 2. Now, number 3, if I have log A to the power n base P. Now, in this case, the input has the power and it will become n log A base P. Okay? And lastly, if I have log A base P is equal to B. This is a logarithmic equation right here. If I want to transform it to an initial equation, it will become P to the power B is equal to A. As if to say the P will take B as its power and equate to the input of the logarithm. In fact, this is how we define logarithm. So with these laws, let us go over to the questions we have for you today. Question number 1. We say log x base 4 plus log x base 2 is equal to 6. We are looking for the values of x that will satisfy this given equation. But the first thing I would want to do is to write this logarithmic equation with the same base. So how do we go about that? It becomes log x 2 to the power 2 plus log x base 2 is equal to 6. What have I done? I only just rewrite 4 in the powers of 2. 2 to the power 2 is same as 4. Now you can see that this logarithmic expression here has been already discussed beforehand. So we know how to simplify logarithm where the base is to a certain power. So how do we do that right here? It becomes log x to the power 1 upon 2 base 2 plus log x base 2 equal to 6. We already discussed how we can simplify this logarithm in this case from the beforehand. Now I want to apply the first law we discussed right here. It will become log base 2, then we have x to the power 1 upon 2 times x is equal to 6. That is the first law we have discussed. And now I want to transform this logarithmic equation to an initial equation. That's the last one we discussed. It's going to become 2 will take 6 as its power and equate it to the input of the logarithm. So it becomes x to the power 1 upon 2 times x to the power 1, of course, is equal to 2 to the power 6. And now I can apply the law of indices here that says if you have a to the certain power n times the same base to another power n or to the same power, it can be expressed as a to the power n plus n. So how do we simplify this? It becomes x to the power 1 upon 2 plus 1 is equal to 2 to the power 6. Yes. So let's take this to the other side of the board. We have x to the power 1 upon 2 plus 1 is equal to 2 to the power 6. Of course, how do we simplify this fraction? Right here I have 1 upon 2 plus 1, which can be written as 1 upon 2 plus 2 upon 2, and this will give me 3 upon 2. So I have x to the power 3 upon 2 is equal to 2 to the power 6. Now we want to obtain the value of x. So I'm looking for a way to get rid of this power here. And how do we go about that? We just look for the multiplicative inverse of 3 upon 2, which is 2 upon 3. So we take the power of 2 upon 3 of both sides. Okay, so we have x to the power 3 upon 2 is equal to 2 to the power 6. We take the power 2 upon 3 of both sides. Okay, so with that we can easily eliminate these powers of x. And right here, x is now the subject of the equation. And you can see that this can be 6 over 1, and 3 can cancel out 6, remember 2, and 2 times 2 is 4. So we have 2 to the power of 4 right here. And if you want to simplify further, your answer will become x is equal to 16. That's 2 to the power of 4 is 16. Thank you very much for watching. I believe this video has helped you. Thank you. See you in our next tutorial. Bye.